So after scope, I come back to our variables, uh, which are local variable and global variable. First one is local variable. A local variable is defined inside a function and is not accessible outside the function. On the other hand, a global variable is defined outside all functions and is accessible to all functions in its scope. Uh, Local variables. Let's have a detail on local variables. A variable defined inside a function mean defined inside function body between the braces is called a local variable or automatic variable. Its scope is only limited to the function where it is defined. In simple terms, local variable exists and can be accessed only inside a function between two curly braces. The life of a local variable ends when we close the braces, or when we means when the function exits. Let's have an example for the local variable. In this example, we start our program, and first of all, we declare a function with the data type white and with no arguments. Y test, then we start our main function. In our main function, we declared a variable int var is equal to 5. This is a local variable and it is only accessible uh, in main function body. Then we call our function test, and after function test we want to use var1 is equal to 9. This var1 is, we see that we declare in the function body. So function body y test, and into the body of the function we start between the two curly braces we declare another variable with the name var1. So we pass a value a 6 to this var1 variable, and now this var1 variable is a local variable for the function test, because we are only able to use this var1 between these two curly braces. Outside of these two curly braces we are unable to use this variable. Similarly, as we define another variable in our main function and we name it var. So if we use that var in this function body, we write cout var. This is an illegal because we are not declared inside test function. var is declared in main function and it is only usable in the main function body. So the variable var cannot be used inside test and var1 cannot be used inside main function. Sometimes keyword auto was also used for defining local variables, as uh, we see we define two variables int var and int var1. If we use auto in var or auto int var1, it is also legal, but in latest C++ compilers, auto has a different meaning and should not be used for defining local variables. Second time is global variables. If a variable is defined outside all functions, then it is called a global variable. The scope of a global variable is the whole program. This means it can be used and changed at any part of the program after its declaration. Likewise, its life ends only when the program ends. Have an example of global variables. In this example, we First of all, after the header files, we declare a variable int c is equal, and we pass a value 12 to this variable. Now this variable int c is declared in the starting of the program instead of into the main program or into the function, any function. So this variable int c is equal to 12 is called global variable. After declaring our variable, we declare our function test. Again, it has no return value and it has no arguments. Then we start our main program, and in the parentheses of the main program, we first of all we want to increment our global variable c. We write plus plus c. Then we want to print its output on the screen. We use cout, and we see. Then we call our function test. Then our main program is end. When we call our function, then we define the function body void test int void. In our function body, we once again increment our global variable. We write plus plus c, and again we want to show its output on the screen, so we write cout is equal to c, and then we close our function. What is the output of this program? The output of this program is 13. When we print the value of c in the main program, it prints show its value 13, and after calling the function, it prints its value 14. In this program, c is a global variable. This variable is visible to both function main and test in the above program. So here is a warning. Now that you have had a basic introduction to global variables, I must warn you to restrict your use of them. When beginning students first learn to write programs with multiple functions, they are sometimes tempted to make all their variables global. When students make all their variables global, this is usually because global variables can be accessed by any function in the program without being passed as arguments. Although this approach might make a program easier to create, it usually causes problems later. The problem caused by the global variables are listed as global variables make debugging difficult. Any statement in a program can change the value of a global variable. If you find that the wrong value is being stored in a global variable, you have to track down every statement that access is to determine where the bad value is coming from. In a program with thousands of lines of code, this cannot be easy. So functions that use global variables are usually dependent on those variables. If you want to use such a function in a different program, most likely you will have to redesign it so it does not rely on the global variables. Also, global variables make a program hard to understand. A global variable can be modified by any statement in the program. If you are to understand any part of the program that use a global variable, you have to be aware of all the other parts of the program that access the global variables. So in short, as we define global variables before starting our functions programming or our main function programming, and we are able to use global variables, into any functions or into any space between the programs. So when we pass it a value, then we use it again, we pass another value, or we use an increment and decrement. Then the global variables always updates itself on every line of the program. So it is very difficult to find error in the coding where we use global variables. So because of this, you should not use global variables for the conventional purpose of storing, manipulating and retrieving data. In most cases, you should declare variable locally and pass them as argument to the function that need to access them. This is the solution and to avoid global variables. So we have another type of variable that are called global constant. Although you should try to avoid the use of global variables, it is generally permissible to use global constant in a program. A global constant is a named constant that is available to every function in a program. Because a global constant value cannot be changed during the program's execution, you do not have to worry about the potential hazard that are associated with the use of global. Let's have an example with global constants. In this example, first of all, we uh, declare a variable x30. This is called a macro definition. Forget about it. uh, Go to the next line. In next line, we declare a variable int y and pass it a value 10. And before declaring this variable y, we insert a keyword constant. This constant keyword make this variable int y as a global constant variable. It is global because we declare it before writing our main program or any other function. Then we start our main program. Int main, and into the main we use another variable with the keyword constant. Const int z is equal to 30. Now this const int z is equal to 30 is a local integer constant. Then we show the value of x, y, and z, and we clearly see the output that when we want to show the values of x, y, and z, we see that value of x is equal to 30 as we define it as a macro, and value of y as we define it as a global constant variable, and we pass it a value 10, so it shows a value 10, and we also able to use it in the program. So in the last, our local integrated constant variable z, we pass it a value 30 and it shows on the screen z is equal to 30. C++ example, redefine or reassign a content. In this program, we define a variable y. Similarly to our previous program, we use const int y is equal to 10. The keyword const make is a constant global variable. It is global because uh, we define it before writing our program. So after initializing y is equal to 10, we write our main program into our main program. First of all, we want to use the variable constant global variable y, and we want to show its value on the screen. Then we want to change the value of y from 10 to 100. And after changing its value from 10 to 100, we again want to display its value on the screen. We use cout value of y, and then we want to display y. So what happens when this program compiles? This program generates an error because here you can see that we cannot change the value of constant. Here we tried to change the value of y, but there is a compilation error. Uh, because y is equal to 10 and it's a constant value. So any constant value we are not able to change it. So we cannot assign any value to a constant variable. Either it is a constant global variable or it is a constant local variable. Then our type static local variables. The keyword static is used for specifying a static variable. For example, in our main program, if we declare a variable a with a data type float, and if we use a keyword static in front of it, it makes it a static variable. A static local variable exists only inside a function, like a local variable, where it is declared similarly to a local variable, but its lifetime starts when the function is called and ends only when the program ends. The main difference between local variable and static variable is that the value of static variable precedes the end of the program. So in this, so here is an example for the static local variables. First of all, we define a user-defined function test with no return type and zero arguments. In the body of the test, we declare a variable int var and we pass it a value 0 as we use keyword static in front of it. So var is a static variable. Then we want to have an increment in our variable plus plus var. Then we show its value on the screen. Cout var. Okay, then we write our main program. Into our main program we call test function 2 times, and then we end our main program. So the output of the program is that when the first time test program is called, the static variable var shows us 1 because in the test program we declare it with a 0 value and then we increment it. But second times when it uh, called the main same function test, another increment is done into the same variable. So static variables in the above program test function is invoked 2 times. During the first call, variable var is declared as static variable and initialized to 0. Then 1 is added to var, which is displayed in the screen. When this function test returns, variable var still exists because it is a static variable. So variable var still exists with a value 1. During second function call, now new variable var is created. This same var is incremented by 1 and then display on the screen. So when the function is called second time, the var increments 2 times. So it shows us a value 2 on the screen. So here is a question for you. What is the output of previous program if var was not specified as static variable? Mean if we not use keyword static with this variable what happened to the output of this program. So here is the answer. The output of this previous program is 1 1 because it becomes local variables, and always when we end our test function it destroyed its value, and every time we call the function test it uh, creates from the beginning with initialized value 0, so it shows us the output 1 1. Function overloading, the process of declaring multiple functions with same name but different parameters is called function.